First function is here. That e to the power 2y minus y cosine xy dx plus 2x e to the power 2y x cosine xy plus 2y dy equals 0. Okay, now as we can see, for this ODE, we have m, that is n, right? Now follow the steps. The first step, you're gonna calculate partial m over partial y and partial n over partial x, right? And check whether they are exact equation. After you know that they are exact equation, then we can use the integral to find out the antiderivative of fxy, okay? And after you find the fxy, you're gonna pick the terms. Okay, pick the terms and let equal c, and that's gonna be our solution. Okay, that's it. Go ahead, try it. I'm gonna give you guys 3 or 4 minutes. Try it by yourself.
Sorry, a little late.
Oh, it's okay. Now finish this example. Check the whether this guy is exact function or not. Okay. Okay, I'm gonna write down the answer on board. Let's take a look. So the first things you guys needed to recognize what is m function, what is n function. Okay, for the m function, we have e to the power 2y minus y cosine xy. We have nxy now. We want to check whether this guy is exact function or not. Okay, partial n over partial y. We have what? We have the derivative of this guy gonna be a composite or composite function, right? That is a composite function with respect to the y, right? So e to the power 2y. Derivative of the whole thing is going to be equal to self. Then do the derivative for the this function, 2y. And the derivative of this guy, and be careful, that is product rule because we have the y and cosine xy. So we're going to do the product rule. Right. I wish you guys still remember how to do the product rule and still remember how to do the derivative of composite function. And the derivative of the whole thing equal to itself. This guy is 2. And this is itself or equal 1. And what's the derivative of cosine xy? Gonna be a negative, right? Negative sine xy. And since this guy is a composite function, we have cosine xy and it's x. Okay, we can continue. Cosine xy, xy, sine xy. So that's the first derivative, partial m over partial y. And the second one is going to be partial n over partial x. So we're going to do the same things. We're going to do the derivative for this guy will be the coefficient. We treat the other terms with constant 2e to the power 2y going to be constant, right? This one should be very easy. And the second term gonna be the product rule, right? I can write down the product rule. Sorry. Derivative second term. And there's a third term, things that is 2y. Here we do the derivative with respect to the x, right? X, so that means this guy equals 0, this constant. So we can simplify it. And there will be a negative sine xy. And this is a composite function, x prime, right? And we can simplify this guy. Derivative of the xy here's with respect to the x, so we keep the y as a constant. And then we're gonna get okay, so we get the same. Partial m over partial y equals partial n over partial x. So we get that guy is exact equation. Now we can do the integral. The first integral gonna be partial f over partial x. That equals mxy. Okay. And now we're gonna do the integral with respect to the x. Right. And of course, with you, this is a constant. The antiderivative should be x. And this guy is constant. So basically, we're gonna do the integral of this guy should be a sine, right? Sine divided by here is a coefficient y. So antiderivative, the formula should be like sine ax divided by a. Called the constant here, you divided by a. Or you have sine ax dx. That means negative cosine ax divided by a. Okay. Or you say eax dx. That should be divided by a. Okay. Always divided by the constant because we have the coefficient here. Okay. So that's the antiderivative or the integral. So for this case, we have y is a coefficient, right? The antiderivative of cosine xy gonna be sine xy, right? Sine, cosine, sine, and we have a coefficient y because here the variable is x, right? Divided by y. Okay, we got this one. We have cancel out. Okay. Now we're gonna do the integral for the second one. This time respect to the y variable, and the n is what? Is this guy. Okay, and now you're gonna do the integral. We're gonna have these three terms. The thing should be easy if you really understand the formula. Okay, here we'll do the integral with respect to the y, which is the other variable as a constant. So for the first term, 2x is a coefficient, it's constant. We do the integral with respect to the y. So it's e to the power 2y because we have coefficients, right? And for the second term, we have cosine xy, should be a sine xy. And we have coefficient x. And for the third term, gonna be a very easy power rule, right? Power rule. And we're gonna get what? X e to the power 2y and cancel out sine xy plus y squared. Right? Now we combine the terms. Okay, we combine the terms. So fxy I made a mistake. I need to double check. Yeah, we're gonna combine the terms, right? So we have x e power 2y. We have both of them. We have both of the negative sine xy. We also have y squared equals c. And that guy is the solution of ODE. Okay, that's it. That's it. And this problem is a little bit tougher because what? Because I include everything. I include all the knowledge that you learned from your Cal 2 and Cal 3. Okay. For the we use what? We use the check function. What is the antiderivative of the check function? Okay. Check function is a little bit tougher for you guys because you need to memorize the formula, right? And the second one, you also needed to use the product rule when you do the derivative, right? Because when you do the derivative with respect to the y, we have these two y, so it's multiplication. Multiplication, that means a product rule. Okay, product rule. So basically, this problem is very, very comprehensive. And in the test one, I probably will adopt these problems, okay, because it's so comprehensive and include all the knowledge that you learned before, okay. Now, let's move on. Today we're gonna learn a new type of equation we call the Bernoulli equation. A Bernoulli equation. Let's take a look. The Bernoulli equation dy over dx. Okay. Let's take a look at this guy. Here, for n equals 0 and 1, it is linear equation. It's a linear equation, right? If n doesn't equal 0 and 1, we let u equals y minus n. We use the substitution, okay? So it's very clear when n equals 0, y to the power n, power 0 equals what? Equals 1. So that's a typical linear equation. We can use what? We can use y equal to e to the power negative px dx plus e c. I wish you guys still remember such a things before, right? I just write down the formula again in case you forget it, right? If we have a standard linear equation, px and fx, we don't have this term. We don't have this term. We can directly use this formula to solve it. That's what we learned. And of course, when n equals 1, okay? When n equals 1, that means fx times y, right? Now you can combine px and fx. We combine these two terms, it's going to be px minus fx equals 0. So we basically, now the px is what? Is the formula here, px is what? Is px minus fx, okay? And what is fx? Going to be a 0, right? So when n equals 1, that means we combine these two terms, px and fxy, going to be px minus fx. That's going to be the new px, okay? New px. And fx going to be a 0, right? If we combine these two terms. And we still can use such a formula to find the solution, okay? So these two going to be special cases, okay? Special cases, because we can solve it using this formula. Now, what if n doesn't equal 0 and 1? We're going to use substitution, okay? We let u equals y to the power 1 minus n, okay? So let's take a look. The first example. The first example is going to be here. Okay. Now, here we can see the n equals what? N equals 2. If you compare this standard form, here's a y equals to the power n. N is equals 2, right? Very simple. So now that means what? It belongs to the second condition, or it belongs to second case, n equals 2, which is that u equals y minus n, and n is 2. And or you can write down 1 over 1. Okay, u equals 1 over y, and you can solve it. You can solve it. So y equals u 1 over u. Or people like to write down is u to the power -1. Whatever you want. Okay, whatever you want. So now, in this formula, or in this equation, we have dy over dx. Okay, dy over dx. So that means here we let y equals a new u. Okay, we assume that the new is intermediate variable, and we have x. Okay, u is the function of x. Okay, u is a function of x. Now, so what is dy over dx? We can do the derivative of this guy. And of course, you're going to use the composite function. Dy over dx here is what? We do the derivative of this guy, right? Because y equals this one. So the dy over dx, we need to calculate the dy over dx. So, here, right? Here. Dy over dx. So let's take a look. Gonna be a power law, right? Power law, derivative of this guy. And since this is a composite function, we need to put the derivative here. Okay, that's a composite function. We do the derivative firstly, and then du over dx. Okay, so we got a dy over dx, and y can be written down as u to the power 1. So we need these two expressions and plug in to here. Okay, plug it into here. So what are we gonna get? Dy over dx is this guy, right? And x, y is right, because here's a y. And the y squared is gonna be and now we try to simplify it. Okay, now we let this equation times what? Times u squared, or times negative u squared times negative u squared gonna be du over dx, and negative and positive, and u to the power negative 2 times u2 gonna be u to the power 0 is 1. And this guy will be x u, and this guy will be x, right? Because u to the power negative 2 times u power gonna be 1, right? So negative x. Okay, what type of this equation is? I have a question. What type of this equation is? Can we solve this equation or not? Yes, we can solve it. Now it becomes of standard equation, like I said before, dy over dx, px, y equals fx. You still remember? Okay. So this guy has a solution like that, right? Now you can solve it. Because now the y is u, right? Y is a u. Y is a u. So px here is negative 1 over x. And fx equals negative x. That's it. Now we're gonna use the formula we learned before and just solve it. And the first step, we're gonna do this guy. Okay, and then we use the formula. Px, the integral of this guy is, I wish you guys still remember it, how to use this formula. Dx. The solution of this guy is this guy, right? Plug in here, plug in this formula. So we got this one, okay, this one. And for this one is e to the power ln x, c ln x. And for this guy, you can write down x to the power negative 1, and yes, negative x dx. Okay. And again, Again, this guy will be x, cx. Again, we can cancel out. That's very easy, right? It's a negative. And this guy will give you, and the derivative for 1 should be x times x, x squared. Okay, we got the solution. Sorry, should be a u because this equation independent variable is u. Okay, as I mentioned before, u is just intermediate variable. U equals this guy. So the function is about y. What is y? Y equals what? Y equals 1 over u. Okay, so you're plugging back. Y equals 1 over u should be x minus cx squared. Okay, and this guy is the solution of ODE. Okay, solution of the ODE. So basic idea is very straightforward. The first step, you need to check whether this guy is a Bernoulli equation, n doesn't equal 0 and 1. Okay, if n doesn't equal 0 and 1, we just let u equals what? U equals y minus n. Okay, or 1 minus n. And here n is 2, right? So let u equals y to the power 1 minus n. And then use u to express the y. So we're gonna solve this y, we're gonna get this one, right? And then we do the derivative, okay? Because in this ODE we have dy over dx, so we need calculate the dy over dx, okay? And be careful, here is a composite function, and use a composite function derivative, okay? This is a power rule and du over dx. Okay, after you get these two, you plug in back. Here's the dy over dx, use this one. Here's a y, use this term, and the y squared, we use this term. And simplify it. And after you get this one, and you get this one, that is a standard form. You can use this formula. Okay, use this formula, sorry. Use this formula to solve this type of ODE. That's what we learned before, okay? We learned it before. Now I'm gonna give you guys another example. Let me check the examples. Whether I can find it or not. Take a look, this guy. Try this one for me. It's very clearly, we can tell here the n is what? Is n is a negative one, right? It's a negative one. So it belongs to a second case, divided by itself. Okay. Just follow the steps. Use the substitution. Let u equals y to the power 1 minus n. Here n is a negative 1. Okay, I'm gonna write down the answer on board. So it's very clearly that a guy belongs to the second case. We can see n equals -1, right? So now we can write down the substitution. U equals y to the power 1 minus n. And the y can be written down as what? Y can be written down as, we solve the y. We can, so u to the power 1/2. Right? We can solve it. U equals y squared. So y squared equals u. Y equals u to the power 1/2. Or square root of u. Okay, whatever you want. Now we need 2/10. Another one is dy over dx. Right. Now we do the derivative for this guy. Use a power rule. Power rule gonna be and the du over dx. And the 1/2 u again. Now we can plug in. Right, plug in. Plug this in to here, and the y term is here. Right? Use these two to substitute the y prime and y. So we have what? Right, and this guy will be 2 over x, y is and y to the power -1 gonna be u to the power -1/2. Right? And then we can try to simplify this guy. We can let the equation times 2 and u to the power 1/2, okay, times this term, right? Because here's a negative, we times u positive. Here's a 2, we times 2, okay? Our goal is transform this guy to the standard form, okay? After you times this guy, cancel out, u times this guy will be u to the power 0, going to be 1, right? And times this guy times this one will be 2 times 2, 4. U to the power 1/2, 1/2 is u. And 2 is 4. This is here is 0, right? Is 0. Or you can write down like that, 4 over x, right? 4 over x. So now you can see px equals and fx equals this guy, right? So now you can use a formula we learned before, right? So integral okay, and then we're gonna have what? We have what? We have 4 mx, 4 mx. Right. So this guy will be x to the power 4. And this guy. So x power 4, c x power 4. And this guy will be okay. We continue to simplify this guy. Put a 4 outside. 4 is constant. And this guy can be written down it's like that. Okay, now you can use power rule. Again, negative 4. And here is 2 power 4. Here, negative 4, 4 cancel out, negative. And this guy, we are gonna give you 1c. Okay. Let me check the formula. Oh, sorry, I'm making a mistake here. Supposed to be the C here. Sorry. Here's a U. I'm making a mistake. C shouldn't be here. Okay, because then we're gonna get what? then we're gonna get, because we know the formula. I'm sorry, I made a mistake with the formula. Right? Formula should be like that. If you still remember, the formula still should be like that. Let me check the last example, whether I make mistake or not. Okay, and the answer should be like that. If the let's take a look at the last example. Sorry, the last example I made the same mistake. Should be here is a C. Okay. So we're gonna get CX. So the last example should be like that. Here's a C, C, C. You put a C in the first term. Okay, in the first terms. I make a mistake because I put the constant here. The formula should be here. Right? Formula should be like that. Sorry about that. Sorry about that. Okay. You guys need to memorize this formula. That's a requirement. That's the requirement. Okay. So for this case, we got what? We got cx to the power 4 minus 1. Is that over? No, it's not over. U equals this guy. Here is about y, right? So we're gonna plug in back. So we know y equals what? Or u equals y squared. You plug in back, u equals y squared. Y squared equals cx to the power 4 minus 1. And then we're gonna get square roots. You understand? Okay. So that's the solution. That's the solution. I'm gonna give you guys one more example. Let you guys try it again. Okay. I change a little bit. So I change it like that. Let you guys try it again. and follow the steps. Okay, follow the steps. The first step, like you need to check the n, and then let u equals y to the power 1 minus n, right? And after that, what are you gonna do? Well, you're gonna do the derivative, and then plug in back. Okay, I'm gonna write down the answer on board. I'm gonna show you the answer. Okay, so here n equals -1, right? So we're gonna let u equals what? U equals y minus y to the power 1 minus n, right? And again, we got this one, and then what? We have y equals u to the power 1/2. Then we dy over dx. Very similar to the last example. We use the power rule. We got this one. Now, actually, you need these two parts, right? And plug it back. You're gonna get oh, sorry. Here's the y. I'm missing the y. Yeah. So okay. So after you got this one, what are you gonna do? Times u to the power 1/2. Right? for both sides, because when we want to cancel this 2, we always want to keep this coefficient with 1, right? Then we can transform that guy to the standard form, and then we can use the formula. So we have we times the positive to here's a negative, so times the positive. So U 6. Okay. Now we can see the px is negative and the fx, right? And we can follow the formula. Right? And then c e to the power negative x to the power 6. Put the constant outside. Right? And again, you can see that power rule. And we're gonna get what? Right? Cancel out. We're gonna get. Okay. We got this one. Very good. Oh, sorry. Get this one. 6 cancel out. Right? Should be a -1. Now, I always make a mistake here. Sorry, I always make such a mistake. So that's a habit, because here is about u, right? We plug in the u. So put here u, and u equals what? U equals y squared. Right? Y squared. So y equals square root of, like that. Okay. Is that clear for you guys? Or you can write down as positive or negative, because when you do the square root, you can write down positive or negative. Okay, positive or negative. And for the last example, you can write down the positive and negative, because when you do the square root, you always give you 2 solutions, right? Positive and negative. Okay. So in case you guys forget it, I put a negative here. Okay. Okay, I'm gonna wrap it up.